Welcome to Bedtime Astronomy. Explore the wonders of the cosmos with our soothing Bedtime Astronomy podcast. Each episode offers a gentle journey through the stars, planets, and beyond, perfect for unwinding after a long day. Let's travel through the mysteries of the universe as you drift off into a peaceful slumber under the night sky. Here's an overview of the main astronomy discoveries from 2024. January 2024. James Webb Space Telescope, JWST, Deep Field Observations. Early in January, JWST released stunning images from its Cycle 1 observations, focusing on some of the most distant galaxies ever observed. These observations provided insights into the epoch of reionization, offering clues about how the first stars and galaxies formed. The data suggested that these early galaxies were much brighter than expected, challenging existing models of galaxy formation. Discovery of exoplanets. Astronomers announced the discovery of several new exoplanets through the Transiting Exoplanet Survey Satellite, TESS. One notable find was a super-Earth in the habitable zone of its star, potentially offering conditions suitable for life. This discovery was part of a broader effort to catalog Earth-like planets that could be future targets for detailed atmospheric studies with JWST. Advancements in cosmic microwave background. New data from the Atacama Cosmology Telescope, ACT, improved our understanding of the cosmic microwave background, CMB, revealing more precise measurements of the universe's age, content, and evolution. These findings supported the Lambda CDM model but also hinted at some anomalies that might suggest modifications to our current understanding of cosmic expansion. February 2024. Black hole insights. A team using the Event Horizon Telescope, EHT, provided new data on the supermassive black hole at the center of our galaxy, Sagittarius A star. This data refined measurements of its spin and magnetic field, offering more insights into how black holes affect their surroundings, particularly in terms of jet emissions and accretion processes. Gravitational wave detection milestone. The LIGO-Virgo-Cadra collaboration announced the detection of gravitational waves from a neutron star merger that occurred 700 million light-years away. This event was particularly significant because it was accompanied by a gamma-ray burst, providing a multi-messenger observation that further confirmed theories about the origins of heavy elements in the universe. New satellite launches. NASA launched the PACE, Plankton, Aerosol, Cloud, Ocean Ecosystem satellite on February 8, aimed at studying ocean biology and atmospheric science. This satellite's data will contribute to climate research by monitoring phytoplankton, which plays a crucial role in the carbon cycle. March 2024. Breakthrough in dark matter. The Dark Energy Survey, DES, released analysis showing the most detailed map of dark matter distribution in the universe to date, using weak gravitational lensing. This map helped in understanding how dark matter influences the large-scale structure of the universe, corroborating theories about its gravitational effects. Comet A3, Suchinchen Atlas, observations. Although not a celestial event in the conventional sense, the comet made headlines for its proximity to Earth, allowing for some of the best observational data of its kind. This comet, which won't return for another 80,000 years, provided insights into the composition of the early solar system. Innovations in space weather prediction. NOAA and NASA announced advancements in predicting solar activity, particularly in relation to solar flares and coronal mass ejections. These improvements were crucial for satellite operations and space travel safety. April 2024. Discovery of ancient supernovae. Using data from the Hubble Space Telescope, astronomers identified one of the oldest known supernova remnants in a distant galaxy, providing insights into the life cycles of stars in the early universe. This supernova was from a time when the universe was only about 1.3 billion years old. Mars exploration updates. The Perseverance rover on Mars made significant progress in its sample collection for the Mars Sample Return mission. The samples gathered included some believed to contain signs of ancient microbial life, setting the stage for future detailed analyses back on Earth. Quantum entanglement in space. An experiment conducted by the Chinese satellite Missius demonstrated quantum entanglement over unprecedented distances, opening new avenues for secure communications in space and potentially revolutionizing how data is sent from space missions. May 2024. Discovery of exoplanet atmospheres. One of the significant discoveries in May 2024 involved the detailed analysis of exoplanet atmospheres. The James Webb Space Telescope, JWST, provided new data on the atmospheric composition of several exoplanets, confirming the presence of water vapor, methane, and signs of high-altitude clouds on planets orbiting nearby stars. This was a crucial step in understanding potential habitability and the chemistry of extrasolar worlds. Solar activity peak. Although not a celestial event in the traditional sense, the solar activity in May was notable as it was part of the strongest geomagnetic storm in over 2 decades. This storm had profound impacts on space weather, affecting satellite operations and communication systems. Researchers at NASA's Goddard Space Flight Center provided insights into how such solar events can influence Earth's technological infrastructure. Advances in space radiation research. NASA researchers made strides in understanding the effects of space radiation on human biology. Using lab-grown human brain models, they studied the impacts of simulated space radiation, which is vital for planning long-term space missions, especially those to Mars. This research was highlighted as part of NASA's preparation for the Artemis missions. June 2024. Lucy spacecraft's discovery. In June, NASA's Lucy spacecraft, while exploring the main asteroid belt, made a significant discovery by identifying the first contact binary celestial body orbiting a larger asteroid, named Dinkinish, and its satellite Salam. This was a remarkable find as it provided new insights into the dynamics of asteroid systems and the formation of the solar system. Launch of PACE satellite. The Plankton, Aerosol, Cloud, Ocean Ecosystem, PACE satellite was launched by NASA on February 8, but its scientific contributions began to be fully appreciated in June. PACE's data collection on ocean biology and atmospheric aerosols started to reshape our understanding of marine ecosystems and air quality, influencing climate models and environmental policy. July 2024. Study of supernova remnants. A collaborative study using data from both the Chandra X-ray Observatory and the James Webb Space Telescope was published in July, focusing on the supernova remnant Cassiopeia A, Cas-A. This study shed light on the Green Monster, an unusual structure within the debris, offering new theories about the dynamics of supernova explosions. Solar ultraviolet observations. The Solar Ultraviolet Imager, SUVI, on the GOES-West satellite captured significant solar activity in mid-December 2023, but the analysis and implications of this data continued into July 2024. These observations improved our understanding of solar activity cycles and their impacts on Earth's space weather. August 2024. Space policy developments. August saw major announcements in space policy, with various countries enhancing their space programs. Notably, there were developments in international space law, with discussions at the United Nations Committee on the Peaceful Uses of Outer Space, COPUOS, focusing on space debris mitigation and the sustainable use of space resources. This was particularly relevant as more nations planned lunar missions and further exploration of Mars. Technological advancements. SpaceX continued to push the boundaries of rocket reusability with further successful landings of their Falcon 9 and Starship vehicles. These advancements not only reduced the cost of space travel but also paved the way for more frequent and ambitious missions, including plans for human settlements on Mars. New insights from Mars. The Perseverance rover on Mars continued to send back valuable data, but in August, a particular focus was on the discovery of potential signs of ancient life, or at least the conditions that could have supported it. This included the analysis of rock samples that might contain biosignatures, furthering our knowledge of Martian geology and history. Comet research. While not a visible event, research on comets continued with new data from previous observations being analyzed. This included studies on Comet C/2023A3, which had passed Earth earlier in the year, providing insights into the composition of cometary nuclei and the solar system's early history. September 2024. In September, several groundbreaking discoveries and events marked significant advancements in astronomy. One of the key highlights was the announcement of new data from the James Webb Space Telescope, JWST, which provided unprecedented clarity into the atmospheres of exoplanets within the TRAPPIST-1 system. This data suggested the presence of water vapor in the atmosphere of one of these planets, hinting at potential habitability conditions. This discovery was met with excitement from the scientific community, as it furthered our understanding of conditions conducive to life beyond Earth. Additionally, the European Space Agency, ESA, launched the Ariel mission, aimed at studying the chemical composition and thermal structures of a diverse sample of about 1,000 exoplanets. This mission was poised to explore the chemistry of these alien worlds in detail, potentially identifying if any of these planets could support life. October 2024. October brought news of a collaboration between NASA and the National Radio Astronomy Observatory, NRAO, where they released images from the Next Generation Very Large Array, NVLA, project. These images depicted details of star-forming regions that were previously unattainable, offering insights into how stars and planets form. This data was crucial in understanding the initial conditions of solar systems, including ours. Another major event was the confirmation of gravitational waves from a neutron star merger observed by the LIGO and Virgo collaborations. This event allowed astronomers to study the physics of neutron stars in detail, shedding light on the behavior of matter under extreme conditions and providing a new test for Einstein's theory of general relativity. November 2024. The month of November was dominated by discoveries related to dark matter and dark energy, thanks to the Dark Energy Spectroscopic Instrument, DESI. DESI provided the most precise measurements to date of the expansion rate of the universe, which in turn helped refine models of dark energy, the mysterious force thought to be accelerating the universe's expansion. These measurements could potentially lead to new physical theories if discrepancies with current models continue to emerge. Also, a new type of supernova was observed, which astronomers classified as a hypernova. This event was exceptionally luminous and long-lasting, suggesting a new mechanism for supernovae explosions that could involve the collapse of extremely massive stars. This discovery challenged existing theories about stellar evolution and supernova explosions. December 2024. In December, the Hubble Space Telescope captured its closest ever look at a quasar, providing detailed images of the material around this supermassive black hole. The images revealed complex dynamics of gas and dust, contributing to our understanding of how quasars influence their host galaxies' evolution. Moreover, the Parker Solar Probe made significant observations of the Sun's corona, offering new data on solar wind and magnetic fields. This mission's findings were crucial for improving solar weather predictions, which are vital for protecting both space and ground-based technologies from solar storms. Lastly, a team of astronomers announced the discovery of the first binary stars orbiting a supermassive black hole at the center of the Milky Way. This observation was pivotal in understanding the dynamics and gravitational effects of black holes in our galaxy, providing a new perspective on how stars can coexist in such extreme environments.